Hey guys, my name is Mr. Navarrete, and I am a teacher here at Maynard Early College. I teach pre-cal and calculus. Today, I'm going to teach you guys about rewriting radicals. So you're probably thinking to yourself, what is a radical? Well, you've definitely seen them before. It is this symbol that I've drawn right here, but it can also be represented with a number in the front. For example, if I write the square root of x, well, that means I'm using a radical symbol with no number outside. That means it's a square root. I can also see a radical with a 3 on the outside. That is read cube root of x. So in other words, I'm looking for a number multiplied by itself 3 times to give me this number inside. For example, the cube root of 27 would be 3 because 3 times itself. 3 times gives me 27. Over here, we have some other examples, some more complex ones. The 7th root of x, we don't really call it have a special name for 7th root, and we rarely see that, but we can see any number out here is my point that I'm trying to illustrate right here. And then we can also see it where we have a number, an exponent inside of my expression. So I can say this would be read the 4th root of x to the 2nd power. And that's what we're going to be dealing with today. How can I rewrite something like this so that instead of in radical form, I have it in a different form? So in your math careers, you're going to see that it is often very convenient to rewrite in radical form. Rewrite a radical in exponent form, and you'll see why today. So to rewrite an expression from radical form to fractional form, some people call it, again, fractional form, you're going to remember that the exponent, which is the number that's inside of the radical, goes on the top of your new fraction, and the root, which is the number that's outside of your radical, goes on the bottom. So keep that in mind. So here I have the 5th root of 3 to the 2nd power. Now I might not know what that is, and it's okay if I can't do this without a calculator, but I can at least rewrite it in fraction or fractional form. So remember that the number inside, or the exponent, goes on top. So I'm going to rewrite 3 the way it is. I'm not changing that. All I'm doing is rewriting this so that there is no more radical symbol anymore. So again, the number in the exponent right here goes on top of my fraction. So I'm going to have a fraction in the exponent here. And the number on top comes from the inside, and the number on bottom comes from the outside. So the 5th root of 3 to the 2nd power can be read as 3 to the 2 over 5 power, where my top number came from the inside, my bottom number came from the outside. Okay? So the inside number goes on top, the outside number goes on bottom. Let's go ahead and try one more to make sure we got this. So let's say I have the 8th root of 15 to the power of 7. So again, I'm going to write this as 15, and then we'll fill in the rest. To the power of what number is inside, that number goes on top of my fraction. So 15 to the power of 7 is on the inside, so 7 goes on top. What number is outside? That number is 8, so 8 goes on bottom. So again, keeping with, if we want to keep color coding it, 15 to the power of 7, 7 goes on top, and then the 8th root goes on the bottom of the fraction. So these numbers might not be easy to calculate the way that they are. Maybe that's not a benefit, but I'm about to show you the benefit that we can get from rewriting in exponent or fractional form. So let's say I have this term, the cube root of 3 squared times the 4th root of 3 to the 3rd power. Well, what I want to do first is what I did in the previous example, rewrite it in so that the radical goes away and I'm left with an exponent that is a fraction. So I'm going to say this is 3 to the number inside is 2, so that goes on top. The number outside is 3, so that goes on bottom of my fraction. Times, and then the next one is 3 to the power of, again, inside is 3, outside is 4, so 3 over 4 power. So now I'm thinking to myself, well, I still don't have a calculator. This number's probably going to come out pretty weird, but what I know is that these two share the same base. So since they share the same base, we've already covered what can we do with their exponents. And the answer to that is we can add them. So I'm going to show you how to do this step by step, and then we'll go to the shortcut in just a minute. So We can add them, meaning we can combine them with the same base. Since the bases are 3, it'd be 3 to the power of the first term, 2 over 3, plus the second term, 3 over 4. Now, obviously, we can simplify this number, maybe not as easily in our head as we have been able to before because we've been dealing with whole numbers, but we have two fractions that we're adding. So what we want to do is we want to go ahead and make sure they have the same common denominator. So 3 and 4, well, the least common multiple between those two is 12. So I would multiply my first fraction by 4 over 4 and my second fraction by 3 over 3. So this is all going on inside of the exponent. So my final answer, I'm going to take two more steps together, get there, is going to be 3 to the power of 4 times 2 is 8 over 12, plus 3 times 3 is 9 over 12. Now I can add those up to get my final simplified answer, which will be 3 to the power of 8 plus 9 is 17 over 12. No need to rewrite that as an improper fraction. That would be, sorry, as a proper fraction. That is already improper. So that would be how I solved this problem. Again, what I did, I had these two radicals, I switched them over to fractional form, and then I was able to add those two exponents because I'm multiplying their bases, and then I end up with an exponent of 17 over 12. We may still not know what this number is without a calculator, but at least we have simplified our original expression. So let me show you that alternative, quicker method, if you will. Some of y'all are saying, oh, this is going too slow. I need a faster way to do this. So the alternative method is to add these two fractions, but on the side. So I'm going to go ahead and put side work over here. And I'm going to say, well, 2/3 plus 3/4. I'm going to do the exact same process as I did over there. I know that if I convert these to a common denominator, I'm going to multiply this one by 4 over 4 and this one by 3 over 3. So then I get 8 over 12 plus 9 over 12. And then I can add those in my head, and instead of writing it in my work, I can just jump straight to my new exponent, which would be 17 over 12. So it's the same things, except I'm leaving this as scratch work, as side work. Doesn't need to be in my answers. I still end up with the same answer, the same result, but I didn't have to write as many steps to get there. All right, so let's go ahead and go to our final example for today. So now we're dealing with a radical, but with no number on the outside. That's the most familiar one, and those are the ones we call square roots. So that's how I know my number on the bottom of each of these fractions is going to be a 2. So let's figure out what we have when we rewrite both of these. This is a 10, by the way. They both have bases of 10s. And if you see these spot stains, it's because I'm saving paper, all right? I am writing on the back side of that, the previous paper, and those things just bled through. So just try to ignore them. So 10 to the power of 6 goes on top, and 2 goes on bottom. And then over here, I have 10 to the power of 8 goes on top, and 2 goes on bottom. Now, I know you guys are going to get to this shortcut in a minute, but I'm going to explain the rest of this without the shortcut. So I have 10 to the 6 over 2 times 10 to the 8 over 2. So these happen to be the same denominator, so they're going to be super easy to add. I guess I should have started with this one. But either way, I'm going to get the same result, and I'm going to say 10 to the 6 over 2 times 10 to the 8 over 2. Since I'm multiplying, this will be 10 to the 6 over 2 plus 8 over 2. Right? I would add those two numbers since I'm multiplying the bases that are the same. And then finally, I would end up with 10 to the 6 plus 8 is 14 over 2. Now, this simplifies. The last one didn't. This one actually does simplify to 10 to the power of 7. So that is my answer. So this one actually does help us simplify and actually does help us easily calculate the number. So again, I might not know these two numbers, but when I rewrite them and then add their exponents, I would say that my answer is a 1 with 7 zeros on the end. So it's super duper easy, and it helps us a lot. Now, again, like the last one, I showed you the other method. Let's go with method 2, the quicker one. So there are two shortcuts here for that quicker one. So first of all, I know I have 10 to the power of 6 over 2 times 10 to the power of 8 over 2. Well, guess what? You can simplify that. Simplify whenever you can. It's super duper. It makes your problem a lot easier. So the quicker you simplify, the better. So 6 over 2 simplifies to 3. Let me go ahead and draw a line here to indicate that I'm trying a different method now. And then 8 over 2 simplifies to give me 4. So now all I got to do is add these two exponents since I'm multiplying, and I get 10 to the power of 7. Bam. Work smarter, not harder, y'all. I got the same answer. This one took me 3 fewer steps. So just a final recap, and you're done with me. Remember, we first figured out radicals can be rewritten as exponents by taking the exponent, putting it on top, and the root, putting it on bottom. Inside goes on top, outside goes on bottom. Once you do that, then you can do your assignment that is due on Friday, where you have to, if you're multiplying two terms that involve radicals, you have to rewrite them first, and then depending on your operation here, in this case we're multiplying, then we can add our exponents. This one was a tougher one because the denominators were not the same, but in the example that you just saw, we saw that it does become easier when those roots are the same, when the denominators turn out to be the same. So I hope you guys learned a lot today, and good luck on understanding how to convert between a radical form and an exponent or fractional form.